Hey everybody, let's go ahead and start this next lesson, which is going to cover completing the square. All right, we're continuing along our journey here of solving quadratics and figuring out how to, just find the different solutions for quadratic equations. And this one's a little bit odd. It's called completing the square. It's got kind of a weird name to it. But essentially, when you guys complete the square, you want to end up with a perfect square trinomial, PST. You want one side of the equation to be a PST, and like with anything we do in algebra, it's become more clear once we do some examples here. But if we fill in these blanks here, it says to complete the square for the expression x squared plus bx square the half, and I got rid of this, of the coefficient of the term bx. So basically we're going to, whatever is the coefficient of that term, the bx, the coefficient is going to be b. You want to take half of it, and then you want to square that. So this will make more sense, like I said, once we get into some examples, and you'll see how this works. But it's called completing the square. So let's look at our first example here. And there is our b term, that's the bx. And I should have read the directions before we started, but it says find the value of c. We're ultimately looking for what this value is. That's kind of the unknown here, by doing this thing called completing the square. All right, so we want to find the value of c that makes the expression a perfect square trinomial. Then write the expression as the square of a binomial. All right, so what that means is, like I said, let's kind of start with that bx term, which is 8x in this case. So you just have to take 8 and divide it by 2. And then 8 divided by 2 is 4. That's, if you need to get your calculator out for that, hopefully you don't need a calculator for that, but I did. I needed to use that. I had to ask my mom for help too. But anyhow, we had to do that. And then what you want to do with that is then square it. All right, so the first step was to take half of 8, and the second step is going to be square that value from what we got before, not square 8, but we're going to square the 4. Okay, so 4 squared is equal to 16. Okay, and so that's what we end up getting for c. So c equals 16. All right, now writing all this out, you get x squared plus 8x plus 16. And I can just write equals 0 if I want. And then the directions say write it out as a square of a binomial. And just to refresh your memory, PSTs come out pretty nicely. If you can recognize them, you know what they are. That's x right there. The middle term, the bx term, is positive. So that means that's going to be positive and that's going to be a positive. And the square root of 16 is 4. You don't typically do that, but you want to write it like this, as a square of a binomial. So there is that's our goal right there. That's our objective. We wanted to get a PST that was factorable, so it looked like a square of binomial. And that's what we got. All right. This next example right here, let's kind of go with flow here. So we got 12. I know it's negative 12. So we're going to divide that by 2. Negative 12 divided by 2 is negative 6. All right, and then what we're going to do is we're going to go ahead and square that. So negative 6 squared is 36. It's positive. Notice that when you multiply a negative times a negative, you're going to get positive. Now, if you put that in your calculator, though, just remember, if you put that in your calculator like without parentheses, and you type in negative 6 squared, it's going to come out negative 36 because your calculator is able to make the distinction between when you use and you do not use parentheses. So if you put parentheses around the negative 6 and then use your caret button, square it, I don't think you need to use your calculator for that, but just to kind of make a point there, negative 6 squared is positive 36. Just want to make sure that's clear. All right, and now it's just a matter of kind of putting it all together. So we've got x squared minus 12x plus 36 equals 0. And then we're going to go ahead and write that as a square of a binomial. So what is the square root of x? Or I mean, what is the square root of x squared? And you get x. The square root of 36 is 6. And the middle term is a negative, so you're going to put a minus in there. So x squared minus 6 squared equals 0. All right? So that's called completing the square. So essentially, for those first two examples there, we were making PSTs. All right? So it's like, what can this value be so that we get a PST? All right? And now this next one right here, the directions say write out each step for completing the square method of solving quadratics. All right, so I'm going to kind of go through this. So the first step is going to be, and I know like when we talked about zero product rule, we talked about making sure that that number equals 0. Don't worry about this. Leave that alone. Leave that there, okay? Which it might go against your instincts, but for completing the square, we can kind of leave. It's okay if we don't put a if we don't make that side equal to 0. We can just leave that as is. All right, so the first step is to find half, or take half. Obviously, I can't spell half. All right, find half of negative 16, which is negative 16 divided by 2, which is negative 8. All right, and then the second step will be to square negative 8, like that. And you get positive 64. And then here's where completing the square comes. This is where it's a little bit different than the first two examples. So here's where you might want to write it out. So I'm going to got x squared minus 16x. All right, and then I'm just going to write plus. I'm going to put a box there. I'm going to put negative 15, and I'm going to put a box there because we're going to put a value in there. All right, and the value that we're going to put in there is going to be the value we just found. Okay, so the next step, step 3, is going to be what we got from step 2. So you're going to add 64 to both sides. So you want to add 64 here and 64 there. All right, so let's clean that up. Now that just all comes together. So you got x squared minus 16x plus 64 equals, and then negative 15 plus 64 equals 49. Okay? And like I said, don't get too wrapped up in whether that's a 0 or not. It's okay that that's not 0. For completing the square, that's not going to be the same method. All right, now the next step is going to be factor the PST side. Now, if you do the completing the square the right way, this side should be a PST. If it is not a PST, then you did it wrong. All right, so that is going to be a PST. I'm going to write it out as a square of a binomial. So I'm going to write x minus 8 squared equals 49. Okay, and then the next step, the last step, is going to be what we just used yesterday. So we're going to apply the square root principle to both sides. And then solve it. All right, so we're going to do the square root of that side. And what we do to one side, we do to the other. And when you take the square root of a square, that undoes the square. So that 2 is now gone. It's 8 minus x. All right. On the right side, it's very convenient that we got a perfect square number there, 49. So the square root of 49 is going to be, and keep in mind, you got to write two answers, plus or minus 7. Not just 7, but plus or minus 7. We have to account for both the solutions there. And now it's just a matter of just solving it, working it out. So we're going to add 8 to both sides. And this is where you want to be careful because you want to split it up into two different solutions. So I'm running out of room here, but I'm just going to kind of work down here. So I've got x equals 7 plus 8, it's positive 7 plus 8. And then the other solution is going to be x equals negative 7 plus 8. So this solution comes out to $15, and this one comes out to be 1. So you just found your zeros, just like we did yesterday. So that is your solution set. Right there. We got 1 and 15. And those numbers represent where the graph of that particular equation, that quadratic, that's where it goes to the x-axis. All right, so that took a little bit of time to go through, but that's because we were writing all the steps out and just kind of being particular about it. So it should be a little quicker as we go through the last few examples here. So example 4, first step is going to be to take half of 6. Half of 6 is 3, and then 3 squared is 9. So I'm going to rewrite it. I've got a squared plus 6a plus 9 equals 7 plus 9. Notice how we added that to both sides. Okay, so the left side, just I'm going to kind of leave that alone. So a squared plus 6a plus 9 equals 7 plus 9 is 16. All right, now the next step is going to be factoring the PST. So if we factor the PST, we're going to get a, the square root of a squared is a, the square root of 9 is 3, and that's a plus sign right there, so it's positive, and then squared equals 16. The next step after that is going to be find the square root of both sides. And just like before, when you take the square root of a square, it undoes the square. So instead of it just being a plus 3 squared, it's just a plus 3. And that's it. So a plus 3 equals plus or minus 4. So then after that, take away 3 from both sides. And this is where you want to be careful with how you express your answer. So we've got a equals 4 minus 3. And then the other one's going to be a equals negative 4 minus 3. So this a is going to be 1, and this a is going to be negative 7. And there you have it. There's your two solutions right there. All right, this keeps moving. And we've got, if I write that in solution set format, I can write that like that. Okay, for this next example here, for example 5, you might notice, and I know this doesn't happen all that often, but you have a GCF. And our GCF is going to be 2. So you can factor out a 2 out of all that. And so then you get 2 factors out. You get h squared plus 10h minus 4 equals 0. And then here's something I really haven't talked about up until this last example here. But all the previous examples, you might have noticed that we've had, and I know that's an a, and a squared and a, but we've had the variables on one side. The variables have been on one side, and the constant, the c, has always been on the right side, on the opposite side of the variables. So same thing right here. See, on example 3, we have the x squared and the x on the left side, and the constant, which is negative 15, was on the right side. And then for these were kind of different, so let's not refer to those. But this, we don't have that. So what we want to do is let's get this negative 4 over here so that it's consistent with the other examples that we did. And we'll write it like that. So we've got 2 and then h squared plus 10h equals 4. And now let's go ahead and go through the whole process of completing the square. So we're going to take half of that term, of the h term. So half of 10 is 5, and then 5 squared is 25. Okay, at this point, I went ahead and you might notice I added 25 to both sides. Now notice, I didn't change the sign. It's plus 25 over here, and it's also 12 plus 25 on the right side. I didn't have to do inverse operations. We're literally just adding 25 to both sides. So now let's factor the left side. I'm going to write that as the square root of h squared is h. The square root of 25 is 5, and that's positive. So like that. And this will equal 29. Okay, now at this point right here, I don't want to do the square root yet because there's still kind of a 2 out there that's hanging out, and we don't want that there. So let's, in order to get rid of that 2, we can't just erase it. Let's divide by 2 on both sides. That in turn undoes the 2's there. This keeps on moving, sorry about that. And you got, I'm going to write up here, h plus 2 squared equals 29 halves. Okay, I would avoid writing 14.5. We don't want to do 14.5. So just write it in ratio form. And then we can apply the square root principle, which means we're going to find the square root of both sides, like that. Okay, now like we've always said, taking the square root of a square undoes the square. So that just becomes h plus 2. Now the tricky part on this one is that we have 29 halves. I'm going to write it like this. Root 29 over root 2. But you have something right here, and this kind of goes way back, and you might have forgot about this, but you have to do this thing called rationalizing. We have to rationalize the denominator. And you might have forgot about this, but in order to rationalize the denominator, you take whatever the radical is in the denominator. In this case, it's square root of 2. So you're going to multiply the top and the bottom by the square root of 2. Okay? So when you rationalize the denominator, the goal is, the objective is to get rid of the radical in the denominator. Because in algebra, we don't like there to be irrational numbers, especially in the denominator. So that gets rid of it. And I mean, some people just say, well, it just goes up to the numerator. Well, there's a little bit more to it than that. But in essence, you're basically just multiplying this side, we're not just multiplying that side, but you're multiplying by 1, because root 2 over root 2 is, if you think of an identity property right there, that's essentially equal to 1. Okay, so what we have here is we get 29 times 2 is going to be 58 over 2. Because the square root of 2 times the square root of 2 is the square root of 4. And the square root of 4 is a perfect square, which equals 2. And there's your answer. So one thing that I have also neglected to kind of do, because there's a lot going on in this problem, we've got h plus 2 equals, and I should have written this before, plus or minus root 58 over 2. So plus or minus, don't forget that aspect of it. And we're still not through with the problem. I know this is a nutty problem, but we're going to subtract 2 from both sides. And these cancel. And this 2 right here is nothing's, it's not really going to interact with on any of that there, because, you could, but at this point in the game, we're not going to do that. So the answer is going to be h equals, I'm going to write it like this. Negative 2 is first, and then plus or minus root 58 over 2. And that is acceptable, okay? And that was kind of a weird answer. It's that's kind of the reason we do quadratics. When you get these weird answers like this right here, it's just, there's not a lot of, actual specific numbers in this one. Square root of 58 over 2 is irrational. Whether it's positive or negative doesn't matter. Square root of 58 is an irrational number. But we can get a pretty good approximation of that if we round, but we're not going to do that. We can just leave that as a ratio. Okay, so that does it. Sorry that last example was a little nuts. I'm going to try to keep, in terms of your assignment, I'm going to try to keep them all pretty straightforward, where they don't come out to such crazy irrational answers. But there's probably going to be a couple in there like that. But just kind of keep that in the back of your head that you have to kind of do that. So that does it, everybody. Everyone have a great day, and hopefully everyone's doing well and staying safe. All right, take care.